All right, so this deep dive is going to be on TripleO debugging, particularly about the Overcloud deployment. So I've already got an undercloud installed, and I am going to just kind of walk through a couple of Overcloud deployments. I've tried to set up some scenarios so that it will fail where I expect it to, and then we can kind of debug those. Some of the failures are a little artificial, but I do think they represent where things often fail. So, I think the techniques and tips and whatnot are applicable to, other types of failures you might encounter while trying to do an overcloud deployment. Yeah, and if there are any questions or anything along the way, just let me know, or any other tips or ideas that you guys have as I'm going along. If you do something slightly differently than the way I'm doing it, let me know. So yeah. All right, so I will get started. What I'm going to do, I've got two terminals here. What I'm going to do is just deploy an overcloud. I've got a simple little script here which just calls OpenStack Overcloud Deploy. So you can kind of see how that looks. It's fairly straightforward. I am using network isolation, and I'm using net single NIC with VLANs. And I have a custom network environment file. So let me show you what that looks like. Pretty straightforward again. These are pretty much the minimum set of parameters that you need to deploy with network isolation. In fact, I don't even think you need to override the external net CIDR if you don't want to. But I've just chosen to do that here, and everything else is fairly normal for a bare minimum network isolation deployment. So let me go ahead and kick that off. So this is going to start deploying. Hopefully, we'll see what happens. Try to move my BlueJeans browser around a little bit so I can try to keep an eye on the chat as well. If I happen to miss someone's question in the chat, someone will just speak up so I can address it. Okay, so this is just running through the fairly normal initial stacks to get created. What this is doing is just pulling events from the overcloud, and you can see here that one of the resources has already gone into an error state. It's the Nova compute resource, and the error is no valid host. So one of the things Heat will do is it will actually retry resources on create a couple of times, and Nova also has retries built in. So this might take a few minutes to actually fail the stack create. But once that happens, we can see the error and what actually went wrong. Can we configure the retries to fail faster? We can. I know that we can on the Nova side. There are retries. Yeah, and Steve is saying that Heat has retries as well. Okay, so while we're waiting for that overall stack to fail, I'm going to go ahead and list the resources in the Overcloud stack. This is kind of one of the first steps I usually do if the stack fails. Just start listing the resources to kind of see what failed. If I make these terminals a little bit wider, can you guys still see the whole thing? All right, well, someone say if you can't. All right, so it's failed now. And if we take a look at what resources actually failed, so down here in my resource list, we can see that it's the controller resource that failed. As Steve showed last week, the OS heat resource group is actually implemented as a nested stack. So if you want to see why this actual stack failed, you can kind of drill down by resource listing this stack. This is going to kind of be a pain with this UUID wrapping, but I'll make do.
If you've got a recent heat client, there's a new command called OpenStack stack failures list, and that saves you having to dig down through so many nested stacks because it basically just recurses through and finds the failed resources for you.
Okay, I can try that. So yeah, that's what I'm doing right now. Is I'm actually just kind of digging down to see what failed, but I just keep doing a resource list until I get down to the final nested stack here, and we can see that the resource now is a OS TripleO server. So that's actually a straight mapping to OS Nova server. If you want to kind of have a look at the error that Heat saved about why this resource failed, then you can do a resource show on this. And resource show takes the stack UUID and the resource name. Okay, so we have a traceback from Nova here. Somewhere in here, yeah, so it says no valid host was found. There are not enough hosts available. Those of you who are kind of familiar with Nova and OpenStack in general, you'll know that that's kind of a generic catch-all message for Nova, but it can still kind of help point you in the right direction. You probably could start looking at the Nova scheduler logs, see why it couldn't find a host, and if you do a Nova list on one of these, you'll actually see that same error. So the error is saved both on the Nova side and in Heat as well. All right, the Nova client didn't wrap that nicely, but it's the same error. So let's just go out and take a look at the Nova scheduler log to see what might have happened. These things are kind of hard to parse mentally. One of the things that's kind of useful to look for in the Nova scheduler log is the individual filter names, and particularly this is a helpful message to look for here. Like this says, filtering removes all hosts for the request with instance ID, blah, 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 and that's the instance ID that we just checked. And we'll see that the filters here, the retry filter started with 20 hosts and it ended with 20 hosts, so that didn't eliminate anything. Same for the TripleO capabilities filter, that still matched 20 hosts. I have 20 ironic nodes registered, by the way. That's where that 20 comes from. And then we have the compute capabilities filter, which started with 20 and ended with 0. So that kind of tells you that that's the filter that couldn't find any hosts to match that filter. So at this point, what you might do is you might go look at what that compute capabilities filter actually does. you could go read the Nova documentation, maybe check that out. I actually don't know how well these filters are documented. The source code for them is actually pretty straightforward, so you could even go look at the Nova source for that filter. Or it's possible that just the filter name kind of clued you into what the error was. So some of the filters are called like disk filter or RAM filter. In this case, it's called the capabilities filter. And that should kind of be a flag that the capabilities on your ironic node are not set correctly. And in fact, if we scroll back up here in the top terminal to the beginning of the deployment command, we can actually see that we had a couple of errors up here and warnings that kind of scrolled by pretty quickly. And if we had read those a little more closely, we would have seen this error a lot earlier. So this is actually telling me that I don't have any nodes tagged with the control profile, and I don't have any nodes tagged with the compute profile. So one of the things that you can actually do to make these errors fail your deployment a little bit quicker is you can add this errors fatal argument to the OpenStack Overcloud Deploy command. This should probably be default to true on its own. It just doesn't right now due to historical reasons and kind of some changes in the way that we've done the validations. But yeah, we should definitely make that fail everything by default. So I'm just going to run this again, and you'll see that it's not even going to call out the heat. It's just going to immediately bail out. So what I'm going to do now then to actually correct the problem is I'm going to tag two of my nodes with the correct capabilities. And that is the command to do that. This command is documented in our documentation about how to tag a given node with a profile. So I tagged one control. I'm going to tag another with compute. All right, now let's run our deploy command again. Now, one of the things you'll notice is that I'm not actually deleting the stack in between these deployment attempts, so it's actually going to do a stack update. The main reason I'm doing that is to try to keep things moving a little bit quicker for the purposes of the the demo here. So yeah, let's see. A couple other things I wanted to mention kind of while we wait for this to deploy. If you know what resources you're expecting to see created, it can sometimes be useful to go out here like I was doing before and use the other OpenStack clients to kind of keep an eye on things, to kind of see how things are progressing. Sometimes you'll be able to spot an error out here before heat actually fails the overall stack deployment. So I can see that I've already got ports starting to get created in Neutron. Likewise for networks as well. What I'm actually going to do is I'm just going to watch the Nova list command. So I've still got my instances that were in error before, and this should actually, we should be able to see some new instances get spawned out here. And when they go to the active state, heat will actually clean up the old failed instances. So that's why you're going to see duplicates at first. So that's expected. But this is just kind of another way you can keep an eye on things. For a virtual environment, Virt Manager is also very useful. Let me pull this over to where it's going to cover up my terminal a little bit at first. But if I connect to this Virt host, This is a remote Virt host, so there's a slight delay. But if I connect to this Virt host, I can see all the VMs I've got defined out here. So as I was saying, I've got 20 virtual ironic nodes defined in this setup. So that's why I have so many, nodes called bare metal. Using Virt Manager and pulling up the console is another good way you can kind of keep an eye on things. So here we can see this node is in the process of PXE booting into the deployment RAM disk. This is going to scroll by pretty quickly, but after a while, you start to see the regular messages that you would expect, and if something goes wrong, you can kind of spot that. That just kind of comes with experience. One of the things to kind of look for here in the RAM disk output is the fact that it's created a nice SCSI target for the deployment. And at this point, I believe it's already contacted back to Ironic to start the deployment. But we'll see. We could actually use Ironic to check that as well. But these should deploy in just about 2 minutes or so. Okay, so that was pretty quick. So then they get shut off at the end, and Ironic is going to power them back on and boot into the image that just got deployed. So we don't actually need to watch this anymore. There's not anything all that interesting on there. Sometimes if there's like an iPXE failure or something, or your nodes are booting off the wrong MAC address, you'll see it on the console there. So that's another thing to check. Because you'll be able to see what MAC addresses were used during the PXE boot. So that the console is definitely pretty useful, whether you're doing virtual or bare metal deployments. All right, so we'll get rid of Virt Manager for now. All right, and we can see up here that our heat stack has moved on to creating further resources after the Nova nodes. And we've down here in the bottom terminal, we've got our 2 instances active. These ones in the error state are going to get cleaned up pretty quickly. Ah, there you go, deleting. So yeah, it's going to clean up the ones that failed previously now that it managed to recreate them successfully. And we'll give this just another minute or two to hopefully hit the next artificial failure I've attempted to introduce. All right, so we'll kill this Nova list. We don't really need that anymore. Sorry about the dead time. I tried to optimize my environment to make this run as quickly as possible, but there's only so much you can really do. So yeah, it's just running through some of the initial deployments. You'll actually notice, like, when you don't deploy storage nodes or object storage nodes, you'll notice like how quickly it runs through these steps here for those node types. It's because those are basically no ops. at that point. So they're still created in heap, but they're just basically no action is really taken, but the resources are still there. So that's why you see that output in a deployment, even though you haven't deployed any nodes of that type. All right, well, I'm going to go down here and start listing the resources in the stack. I can at least have that pulled up when it fails where I expect it to. All right, so it finally failed here. And again, it's going to take a couple minutes for the overall stack to fail as well. But one of the things you can do is if you see this output in your deployment output, you can go ahead and start looking to see why this might have failed. So if we look at the stack here, this is actually the stack name, by the way, and I'll show that down below. So you can kind of use that as a shortcut in the client tools. So this is the name of the stack that failed: Overcloud Controller All Nodes Validation Deployment. So let's take a look at that. So you can actually do a resource list like directly on that stack name, which is kind of helpful if you happen to have that output saved. All right, and it's a structured deployment, and pull up why the heat deployment failed. This is the command you can use to do that. I'm still actually kind of getting used to the new OpenStack commands since the heat client was deprecated. So the deployment show, it doesn't show as much as the old CLI did, but you can pass -- long here to get the actual standard error output. And that's actually a little bit hard to read. You can kind of see what happened here. It looks like it failed pinging some IP addresses. This is kind of, if I don't want to log into the Overcloud node directly, this is something that I usually do. You could set up like a bash alias or function or something to make this a little bit easier. But if you pass that -f JSON argument, it's going to format this output as JSON. All right, and then one of the things you can do is you can pipe that to the JQ command, which a love-hate relationship, but it's pretty powerful in its own right. So I'm just going to tell it to put this key from JSON, and of course I messed up the syntax. Let's try that again. All right, and I messed up the syntax again. Let's try that again. All right, boom, there you go. So now you got some output. All right, you can see that during this validation deployment, we attempt to ping some IP addresses. All right, cool. Let me try that command you're recommending, Steve. OpenStack, stack failures list overcloud. All right, let's see what this looks like. I don't know, it didn't work. Maybe the stack hasn't failed yet. Yeah, that might be it. Okay, well, that's something we can look in afterwards, I guess.
Yeah, I've been using that load. Maybe there could be a bug there if it doesn't work when it's in progress, but some resources have failed.
Yeah,
It might be is it in the process of deleting some resources and then recreating them?
could be. I don't know.
Anyway, never mind.
Okay, so yeah, but let's taking a look at this ping failure here. That's kind of I've managed to get the failure itself is not that interesting, but this is kind of how you would dig down into one of these deployments, get the output, and maybe this is something you can easily fix. In this case, I recognize this IP address. This looks familiar to me. If I cap my network environment file again, you can see that's actually the IP address that I specified as my external interface default route. And I know that that has to be reachable from the Overcloud nodes, and currently it's not. So, at this point, if you're familiar with how network isolation works in a Virt environment, you might realize that you have to route this traffic through the undercloud. And this is in our documentation, although it's not something that you might just know offhand. So, this is one of those things that tends to kind of trip folks up the first time. I believe that TripleO Quick Start will now add this route and interface to the undercloud by default now. So that's good. So I know that's something I need to correct. I've got these commands out here, save. So I'm going to quickly do that. And what I'm doing here is I'm just adding a port to the provisioning network for VLAN 10, which is my external network. I'm going to give it that IP address. I'm going to add an IP tables rule. And again, this is something that's in our documentation. At least it should be for our virtual setup docs. And now I can even, I can double check that I can ping this IP address from the undercloud now, so that's good. One of the things you can do before you just try to run the deployment again is, see if your issue is actually fixed. So I'm going to log into the controller. And let's see if I can ping this IP address now. And I can. So this particular issue should be fixed. So let's just run the deployment command again. And again, this is going to take a couple minutes to get back up to that point. While that's in progress, there's a couple things I can show. This is kind of interesting here up in the stack output. You actually get some events from the previous time you did the deployment. So that's what this create failed is from. So that might be something that is a little confusing, actually. So you actually got some events from the previous run since I'm just doing a stack update. Yeah, so the question in the blue jeans is, can you just do a stack update instead of deleting the stack and starting over? You can, and that's how that's one of the things that Heat is good at, is kind of converging on the known good state. Probably my recommendation for initial deployments, if you don't actually care about the stack that failed, you're just trying to get an initial deployment going, it's probably a little bit cleaner and easier to delete the stack in between each deployment attempt. Just that way you know that you're starting from kind of a fresh slate, but it's not required. There are a couple of bugs in TripleO right now that if you do end up doing a stack update to get your initial deployment, you're going to hit a couple of bugs. But I think those are things that we could fix. Okay, so let me log into the compute node here, because that's actually still out there, it's still up and running. Both the nodes are, but all right. So while we wait for the stack update, we can kind of show some things out on the compute node. If you want to kind of tail the main log of what's happening on these nodes during the deployment, this is the command that I use to do so. The output that you want to see is from this service, os collect config. It just logs to syslog, so you could actually tail var log messages here as well, and like use a grep or something. But I just use journal control and give it the service name. So you can see that on this particular compute node, it's actually in the middle of running the heat puppet hook. And it's just kind of stuck out here. And the reason for that is, well, before I say that, I'll just show some of the other things that you can do to kind of see what Puppet might be doing. So we know it's running Puppet at this point, but you can't really tell what. You don't get a lot of output from Puppet. This is one of the things I do to kind of see what Puppet might be doing. So I'm just showing a process tree here, and I'm telling grep to show me 5 lines after anything it finds Puppet related. All right, so here's the actual Puppet apply command, and you can see as a child process trying to start the OpenStack Nova compute service. So that's actually what the reason Puppet is just sitting out there. So let's check that service to see what it might be doing. All right, so according to systemd, it's been attempting to activate for almost 9 minutes, which is about the time we started our first deployment. So we know that's activating. Why isn't it coming up? We can go check the log. You can see that the Nova compute won't start because it can't reach RabbitMQ. So this is actually fine. This isn't something that we need to fix right now. We know that our controller failed during the deployment, and we're doing a stack update right now. So hopefully that should bring RabbitMQ up on the controller, and then the compute node will continue on. But those are just some of the commands I might run to kind of see what Puppet might be doing. All right, so if you notice up here in the stack output, this is actually the stack that failed last time, and you'll see that it was updated successfully. So you got to update complete, so that's good. So we are going to move past where we failed before. Is there a list of bugs that might happen? I don't know that if we have a specific list of bugs. There might be some out in Launchpad. In fact, I found a couple when I was kind of prepping this content. So I'm going to file a few. We should probably make better use of tags in Launchpad, and then maybe we could collect a set of tags on an Etherpad or something, so people are like, hey, stack update related bugs, use this tag or something. That might be a way to kind of group bugs that are common. All right, so the other question in the blue jeans. The first part, yes, that's correct. It's waiting on a resource on the controller. I don't understand what you're asking though. Can it happen we fail before? What do you mean? Do you want to see it like fail sooner?
Yeah, I was saying that the Nova compute here fails before the Rabbit Cube actually starts on the controller.
Yeah. So I think you're asking, could the OpenStack Nova Compute service fail to start instead of just sitting there in the activating state? Is that what you're asking?
No, so basically my question was like, generally RabbitMQ should be started before the Nova compute should be started if you are doing it manually. So here we are doing it simultaneously, so it's waiting on the RabbitMQ on the controller. So can the Puppet on this server fail before even the RabbitMQ has started on the controller? I mean, is there a possibility?
Yeah, that could be possible. We could express that dependency in the heap templates, so that we actually don't try to start this until RabbitMQ is up. The reason that we don't do that is, a lot of the OpenStack services have retries built in, as you see here. So, we can sometimes deploy things faster overall if we just start bringing things up in parallel and then kind of let the services, reconnect once all of their needed resources are up. So, that's kind of the reason that we kind of chose this path. But yeah, we could express all these dependencies in the templates themselves. We could make the compute nodes depend on the controller. All right, so let me log out of my compute node here. And we are up to Overcloud controller nodes post deployment. One of the other things I wanted to mention is when you see, so earlier I said this is the nested stack name. So you can resource list that to see what happened, and that just failed, which is where it was supposed to fail, so good. So yeah, we got another structure deployment failure here. So let's have that output again. Okay, I'll skip the you guys trying to watch me type JQ. I'll just point out the error here. So this is output from a Puppet run, it looks like. And we got a Puppet error here. Could not find class, bad Puppet class. That's because I randomly typed that into the manifest for this particular node. So, this is an artificial failure that I caused to happen, but, suppose it wasn't, and you got some Puppet error like this. One of the things you can do is go out to that node that failed. Let me just get the IP address of the controller again. I'm going to run journal control again to see the OS collect config output. And just pipe that to less so that I can get some nice line wrapping. If I jump to the bottom here, well, there's a bunch of output, but one of the things you want to look for is the Puppet apply. So if you jump to the bottom and then search up for Puppet apply, you can see, all right, so this is the last Puppet command that ran, and this is the one that failed. We can see the error, that same error right here in the log, and we can actually see the actual Puppet command that ran. So what I like to do sometimes is I like to copy this whole thing still on my controller node. And I was afraid of that. That did not copy paste correctly. Let me try this actually. So let's just pipe that to a grep puppet apply. There we go. All right, so this is the command right after running. So you definitely needed these factor environment variables as well. That's going to influence what higher data files Puppet uses to kind of pull variable values from. All right, so let's just run that locally because, hey, you know, maybe it'll work the second time. You know, let's find out. You're almost always going to get this Mongo error. This is like a total red herring. We really need to fix this. I'm not sure if it's something on the TripleO Puppet manifest or not, but if you see this Mongo error, more than likely that's not your problem. So this is our actual error here, just like we saw. So you know, this is a pretty consistent failure. One of the things we can do is, you know, this is the Puppet manifest right here that failed. So let's just pull that up, and we're like, okay, so or we're including this bad Puppet class, and you're like, you know, at this point you can make changes directly here if you know what you're doing, if you are aware, you know, if you're actually like in the middle of trying to develop a Puppet change or something, you can make changes right now. So I'm like, all right, well, I typoed this class, I don't even want it. So we fixed our Puppet manifest. Let's rerun, see what happens. So we still got our Mongo error, but we're ignoring that. All right, we got a couple warnings. We're already past where we were before, so I'm pretty sure that's the problem. And so yeah, the catalog compiled. So I'm gonna go ahead and kill that. I know that was my issue. What I'm gonna do is go up here, and if I just dump my deployment command again, you can see that the templates I'm using are right here in this directory, in my home directory. So that's where the problem must be. So let me just go out here and edit this manifest. The same fix we made on the controller node. Let's make it for real in our copy of the templates and deploy again. All right. So that's, you know, typically my workflow for how I will try to diagnose a Puppet problem. You know, getting onto the actual node, copying that Puppet apply command. The other thing you can do, a lot of our Puppet manifests are greatly influenced by the higher data on the node, and that's under etc Puppet higher data. So let's say you are seeing a problem connecting to MySQL or something. You know, it's not, maybe it's bound to localhost when it should be bound to the internal API IP address or something. You know, what you might want to do is come out here and start looking in the higher data for how we configure MySQL. So, you know, in this case, we're saying we're configuring heat to look for MySQL on this IP address, that should match up with the other data you see here. So the MySQL VIP, matches that IP address. So this is just an example, but if you're having a problem with a particular service, the HIRA data is often a good place to look as well. Maybe you'll be able to spot something here, maybe you won't, but sometimes if you see IP addresses that don't match how they should, or sometimes if a value did not get templated correctly in the HIRA, you might see like a missing password here or something. I'm trying to think what else I can show while I wait for this next stack failure. Yeah, I don't know, I'm not sure. Nothing too much else comes to mind. We should hit the next failure here shortly. So I think we're actually probably going to run over time. I'm just going to keep going because of the recording, and we'll finish the recording. So, I mean, if you need to leave at 11, go ahead. I'm going to keep doing the whole recording, and then I'll post the whole thing. But we'll probably run till, might take till a little bit past 11. So. So here's one thing that's sometimes helpful. Let me just pull up the OS collect config log again. So this is the output of OS net config. So if you suspect a networking problem, you can kind of search this log for OS net config and kind of see the steps that it's taken. You can see here that it's creating the VLANs and whatnot, and if something goes wrong here, you'd see that output here. This is often a good place to look. All right, we hit a stack failure, actually not where I expected. But what this is saying is this stack already has an action update in progress. Okay, so what happened here is we're doing a stack update, and even though the top level stack failed, let me just jump back to the Overcloud here. Even though this top level stack failed, some of the resources in the nested stacks are probably still in progress. And it's not going to let you update those if they're in progress. So I want to do a recursive list up to 5 nested stacks, which will give you everything in our templates. We don't go any deeper than that. So let me just see if there are any resources in progress. Okay, yeah, so we have compute all node deployment, the one that failed in progress. All right, so this is a little trick you can do to kind of get those to fail, is just restart the heat engine service. So let's do that. When you bounce that service and it comes back up, it's going to mark everything in progress in the failed state. So let's just give that a couple seconds, check again. All right, so no output from that. So we got everything in the failed state now. Let's try it again. All right, Steve is saying in the chat that that's a bug. I actually wasn't sure about that, but so yeah, that's something we could probably fix as well. So yeah, it's gonna take another five minutes or so to get up to that point. Anything that you guys want to see, you guys and gals, sorry, want to see that I could maybe show right here? You got any questions about anything I've shown so far? So one of the things you can do on the undercloud, especially in a virtual environment, sometimes you might see some sporadic failures related to undercloud performance. Could be memory related or a lot of CPU contention. I've actually beefed up this VM quite a bit. However, looks like I'm about to run out of RAM. Maybe I should add some swap real quick or something. See what happens. So one of the reasons this undercloud is using almost 8 gigs of RAM is because I've bumped it up to 6 CPUs. Trying to make heat deploy a little bit quicker, but I think I've kind of passed the sweet spot. I think probably about 4 CPUs is probably about right for the undercloud in terms of, the more heat engine processes you have running, it will parallelize the creation of the nested stacks, the ones that it's able to do in parallel. So, depending on how the templates are structured, you can have, a lot more heat engine processes if you want a lot of your nested stacks getting kicked off in parallel. So that's kind of what I was trying to enable here and make things go a little bit quicker. As you can see, my CPU load here is not too bad. Better keep an eye on this memory though. Are there any recommendations on the undercloud node? So for Virt, I think probably like 4 CPUs, 8 gigs of RAM is about the sweet spot for Virt, I think. For bare metal, you can obviously, you want to go as high as you can. Although the more CPUs you have, the more processes for all of the OpenStack services will be spawned by default. So that could make your memory usage really spike. So, if you have like a 48 core box or something, just starting all the OpenStack services could easily take like 20 gigs of RAM or something. Now you can configure all that so it doesn't spawn as many workers for every single process, but just the out-of-box configuration, it's going to spawn as many based on however many CPUs you have. But if you have plenty of RAM on the undercloud and like 24 CPUs or something on a bare metal undercloud, I don't think you're going to be hitting any bottlenecks on the undercloud side. All right, so this is just going to take another minute or so to get up to where it failed last time. I believe it's going to fail again. SSDs, yeah. SSDs are, they always help, regardless. You have limited SSD space. You probably want to put like varlib on the SSD because then you'd have your database on there, as well as the working directory for Nova and Ironic, where it's going to prepare the QCOW2 disk to actually do the deployment. So that happens under varlib as well. So if you have a limited SSD space, I would probably mount all of /var on it, or at least varlib. Other than that, SSDs always help in general. So yes, I would definitely recommend them if you have access to them. All right, so there's a question from Jody about you're not sure you're able to tell. So you think you've made the changes to fix the error, but from what you can tell, those aren't actually getting applied on the stack updates. Yeah. Yeah, I'm not sure what that could be. I'm not aware of any specific bugs that might cause that problem. So it could be something specific to the issue that you're trying to fix. But, it's probably something that we could get to the bottom of. Let's see, Bob, you got a question about how to get this output without without live access. So yeah, there is a way. We have some debug scripts that will basically run, all these commands like the software deployment show and whatnot to, capture that from, someone's failed stack if you don't have access to the live environment. But that's still a command that we would have to tell them to run to kind of capture that and then send us that log output. I actually think that I either saw a patch proposed or someone talking about a patch to make the OpenStack Overcloud Deployment command go ahead and run the software deployment show if that's where it failed. So if we can start showing that output automatically, then maybe we wouldn't have to tell someone to run a separate command. We could also do things like get a dump of the heat database or something. Okay, so we are at this step again, controller services base deployment step 2, and if I have caused this to fail at the right place, and I believe that this is just going to hang forever instead of waiting for that to happen. Let's just check if it's going to. So let's run our journal control command first to kind of see where we're at. All right, so Puppet is running. It's been running for about 1 minute so far. So it hasn't hung yet, but let's assume maybe it will. Try to keep an eye on that progress by using the little, kind of see what it's doing. All right, so I don't see any child processes spawned from Puppet apply. So that's a little weird. In these cases, if you want to get a better idea of what might be happening, you can try to strace Puppet. So first we need to install strace. Okay, well, I just happened to hit it right at the exact moment, so you can see the command it was trying to run there, but I'm going to try to show it with strace anyway. So I'm going to grab the puppet PID here, and all right, so we're just waiting on a child process. So the output from strace is very verbose. It's not something that I understand all that well, but there are some kind of simple things you can do to kind of if you learn like 10% of strace, it's like 90% of everything you'll ever need. So right here, I know that this is waiting on a child process with this PID. So I'm going to strace that PID instead. All right, so it doesn't look like it's doing anything, or it just did something after a little while. So let's jump up here and see what it's doing. All right, we can see that it actually ran cluster check, which is the same command that we saw in the previous process tree output, because I happened to hit it at the right time. So it ran cluster check, and now it's waiting again. So this looks like some sort of loop to me. It keeps running cluster check in a loop. If you're familiar with what cluster check is, it's actually a command for Galera that checks the Galera cluster. And what Puppet is doing is it's going to keep running this command until the Galera cluster node is synced, and it's never going to get there. So we could just wait for this to time out, or let's just keep kind of digging into it to see why this might be the case. Still not synced, and we know we don't really have any data in our database yet, and it's only a single node, so this really shouldn't be taking that long. We do a PCS status output here. So PCS status is a pacemaker command. It's going to show you all of the resources that pacemaker knows about and their status. And in fact, I see here that Galera is stopped. That's kind of a bummer. So, one of the things we can do is like, well, let's just try to see what happens if we start it up. I can just say Galera here. Okay, so now this is telling me that Galera is unmanaged. Now, I'm not sure what that means. Well, I do know what that means, but I could see how if you're not familiar with Pacemaker, you wouldn't really know what unmanaged means. So, at this point, you might have to go out and check some Pacemaker documentation or do some Googling or something. And eventually you might find that unmanaged, one of the things to check in that case is if Pacemaker is in maintenance mode. And we'll see here that it is indeed in maintenance mode. So putting Pacemaker in maintenance mode is a way to tell it, not to manage any of the resources it knows about. Don't try to start anything if it fails. Don't even try to start anything if someone specifically tells you to, like I just did. So one of the things we could do here to kind of see if this might help things move along is let's try to take it out of maintenance mode. At this point, I might be thinking that, oh, this is in maintenance mode because one of my stack updates failed. So then, that might be the reason. So let me just see if I can move this thing along. And as soon as I do that, HA proxy actually restarts because Puppet moves on. So we got maintenance mode and false now, and cluster check is going to return 200 OK now, so it's saying it's synced. And if we do the PCS status again, we can see that Galera is online now. And some of the other resources are coming up as well. So that should actually help this stack complete, and it probably will complete at this point. So what you might want to do now is kind of figure out how that cluster got put into maintenance mode. And if I'm looking for how a value got set, or how a value is configured, what starts the service, what sets a particular IP address or something, I always start with TripleO heat templates. I mean, it's just kind of the source of everything. And from here, you might have to go out and look at some different Puppet repositories, whether it's, Puppet TripleO or maybe Puppet Keystone or something else. And then from there, you might have to look at maybe something packaging related. You just kind of keep following the rabbit hole down so you can kind of find the source of your issue. But I always start at the templates. So I know that this property is called maintenance mode. So let's just see if there's anything out here related to maintenance mode. All right, and I immediately see that I've got a nested stack out here that sets maintenance mode equal to false. So this is a pretty good indication that this may have been what did it. So I bring this up, and this is actually a nested stack that runs. Actually, I can't tell what spot it runs right now just by looking at the nested stack. I'll have to look at the resource registry for that, but I'll do that next. But I can at least see the software config that got executed. So it's just a bash script. We're just checking if pacemaker is active, and then if it's active, we set maintenance mode to false. And the reason we're doing this is because you don't want pacemaker and Puppet to be colliding with each other over which one is trying to stop and start services. What could happen is if Puppet says, hey, restart Nova API, pacemaker could see that Nova API has gone down and also try to restart it, and you get various weird race conditions. So what we actually do is we set maintenance mode to false before we run Puppet. This is supposed to be guarded by this right here, but the bug is that since I'm doing a stack update, I haven't actually deployed anything via Puppet yet. I only got to the first step that enabled pacemaker. So on the next stack update, this deployment saw that pacemaker was active and it put it into maintenance mode. And so the rest of the steps couldn't complete since they never completed originally, particularly that cluster check. So this is actually a bug in the templates. I actually found this yesterday afternoon when I was trying to prepare for this demo. So that was kind of cool, actually, just kind of running through things and finding this problem. So this is definitely something that we need to fix. We need to make this a little bit smarter to somehow figure out that we only want to put pacemaker into maintenance mode if we've already fully completed the initial deployment. Otherwise, that cluster check command would never complete. So yeah, so that's what put it into maintenance mode. Me manually taking it out is going to fix it. If you want to see what actually triggers this nested stack, you can kind of grep for this nested stack name. And we'll see that it is in this particular environment. Pull that up. We are defining a resource registry here, and this is where that's defined. So when we enable the pacemaker environment, that's what we're doing there. Actually, I showed you the post Puppet pacemaker nested stack. I don't know if anybody caught that or not. And this was actually pre-Puppet. So if I look at, take a look here. Probably need to do is go look at what pre-Puppet does. Oh, I see now. Okay, so this is what's setting maintenance mode to true, this bash script. So what I would do is like, hey, what calls this script? All right, there it is. It's in pre-Puppet pacemaker. So yeah, I don't know if anybody caught that the first time I was showing this, but yeah, there it is in the pre-Puppet pacemaker, which is runs before Puppet. Okay, so how would I fix this? I mean, obviously I just did, I just kind of manually hacked it up, and I'm going to get a create complete here, but I kind of faked it. That didn't really work. So I could either fix the actual bug and try to make that smarter, so that I can figure out how to skip that maintenance mode equals true on the initial deployment if I'm doing a stack update. One of the other things you can do with the resource registry, though, is I can say, hey, you know what? I don't want this to run at all. So I can actually just map that resource, just currently mapped to this nested stack. I can just map that to like OS heat none. So if I dump this value into a little environment file here that I just called pacemaker.yaml, and then include that on my deployment command, then it would skip that step. So, that might be something you might do on the fly if you're just trying to get a deployment to work. And then you would, once you get the deployment to work, you'd want to remember to remove that in the future. But that's kind of how you can influence the commands you're running, if you're familiar enough with the templates. So that's what I would do if I didn't want to have to do the manual hack, but it looks like this is actually going to complete. That's about all I was going to show. So yeah, went to about 11:15, but that's fine. All right. Anybody want to see anything else, or got any questions about what I've shown, or any other tips or anything you guys can think of to share? All right, well, cool. We don't really have like a tips and trick debugging section in our documentation, and we probably should. We have a little bit of stuff, but not a lot of, a lot of things I showed today probably aren't really captured anywhere, and I think it'd be helpful if they were. So, that could be something we might add. So yeah. All right, put your ideas in the Etherpad for next week, and we'll see if we can't pull another one of these together. All right, I will talk to everybody later.
Thanks a lot, everyone.
Yep, see you.
Thank you, guys. Bye-bye.
Thanks, everyone.